Okay, hi everyone, and thanks for coming. We want to talk about the Rollkit. This talk was supposed to be given by our team lead, Manav, but he couldn't make it, so he is here with me on a phone. Manav, say hi.
Hey everyone, I'm here.
Yeah.
We do answer any questions.
Okay. So let's talk about Rollkit. So first, I think everyone knows what sovereign rollup is at this point, but I just want to emphasize one more time. The point of, first of all, the whole modular paradigm is to decouple the execution from the consensus. And usually we separate like 4 different levels: execution, settlement, consensus, DA, data availability. And sovereign rollup, not like the rollup which settles on some L1. Sovereign rollup takes care of its own settlement, so it decides what is canonical chain. It resolves disputes and have its own governance. So that's the key point. The most important thing that makes it sovereign is the ability to hard fork. And no, they don't have to. They are not forced to hard fork. Actually, they can choose if they want to upgrade to the new software version, and if not, they can just stay and have a fork. Yeah. So here Rollkit comes into play. So what is Rollkit? This is the web page we have on the website, the main page of our website, and the point of Rollkit is to empower devs to be able to launch sovereign customizable blockchain as easily as smart contract. So it allows, it's in a modular stack, and it like gives the speed and ease of doing this, because you don't have to take care of many things such as spinning up validators, taking care of consensus and stuff. It's open source, by the way, so everyone can go to the GitHub and see what's going on there, what are we working on. There is a project which shows like what we're doing right now and a bunch of issues. And our goal is basically, as I said, to allow devs to create new classes of rollups very quickly, like not in weeks or months, but in days or even hours. Okay. So what is Rollkit? Briefly. First of all, it exposes a BCI++ client. So it's basically a common BFT replacement. So you can, first of all, on the website, let me get back. On the website, you see we have 3 main points: build with the best, optimize for your needs, take control. The point is that people got used to the Cosmos SDK ecosystem. They use Cosmos SDK. It's proven to be reliable and good. And Rollkit is a replacement for the common BFT, which means that you can actually migrate your existing blockchain project to Rollkit, like to become a sovereign rollup. And also, it's a modular software, like in terms of not modularity in terms of blockchains, but software. So it means that it has a bunch of interfaces, and it's very customizable. Like you can substitute. It gives you freedom basically to substitute the data availability layer. For example, like Avail or Celestia, or another interface which is sequencing. So right now we support centralized sequencer, but we're working on shared sequencing. Also IBC client, also state machine. So everything that is ABCI, that implements ABCI++, can be a rollup. For example, Cosmos, or like some EVM, or just a Cosmos SDK app, and it could be done in different languages as it's like protocol buffers, so it's agnostic from the stack. And why do you use Rollkit, basically? As I said, it has the interchain stack, Cosmos SDK, IBC, ABCI++ unlocks block SDK and connect build by skip, which lets you implement stuff which was not possible with pure ABCI. And yeah, it's a common BFT RPC equivalent, meaning that you can replace it back and forth if you want. So if you want to just give it a try, you can do it. Yeah, also it's very customizable and it allows you to do things like change the speed of block reduction or let the rollup work on the so-called lazy mode, which means that the blocks are produced only when there is something like, or once a minute, for example. DA layer can be chosen. And yeah, we're working on sequencing, delegating sequencing. Yeah, fast time to market. And the sovereignty, which is the most important. So let's talk a little bit more about these interfaces that we have. So as I said, DA, it's a interface for the underlying blockchain, which is the which serves as data availability, not just storage. Bridging, IBC client, sequencing. Right now we support centralized, working on shared and based sequencing as well, and different execution environments such as EVM, WASM, or different other kinds of VM. And we also work on the state validity mode. Right now it's pessimistic, but we work on two others like optimistic and ZK. Mana, do you want to add something?
I would add that, like, so currently the state machine, anything that, like Cosmos SDK, anything that uses Cosmos SDK, can use Rollkit. Like right now, mostly Cosmos SDK is used with Comet BFT, but Rollkit acts as you can think of it as a kind of drop-in replacement to Comet BFT, which turns your application to a rollup. So it's a different consensus engine, and we're sort of modifying it to add different all these modular components that you see on the slide. We're modifying it so that it can support all these things. So you can pick and choose your modular component as different teams compete in their own category. Just want to add that.
Yeah. So the point is that you can switch and experiment. So it gives you flexibility. Okay. Also, you don't need to have upgrade keys when you. So avoid L2's cancel multisig on the bridge contract on the L1 settlement layer. So it's a centralization risk. Yeah. So with sovereign rollup, you can choose basically if you want to participate in upgrade or not, like in the L1, because you're not settling on other protocol, so you don't need upgrade keys for bridging contract. Ability to hard fork. Yeah, as I said, ability to hard fork. And no extra settlement costs, that's right. Because sovereign rollup, they have its own settlement. And Rollkit, by the way, has a full node which does the execution. So that's why it's sovereign as well. Okay, I want to walk briefly through the transaction flow that we have in Rollkit and explain what's going on. So first of all, we have few types of nodes. Like as I said, aggregator or sequencer, block producer is the same. Like aggregator node is responsible for building blocks. It also does the execution, but it's the node that is responsible for producing blocks. Yeah, for like ordering transactions. So user submits transaction to any kind of node. It's being gossiped and gets to the aggregator node, to the mempool. Aggregator node rips the data from mempool and creates data headers and packages them into the blocks. And it gossips back to different nodes, like full node right now. Yeah, light node is still work in progress, but it's on the diagram. Yeah. So after that, sequencer or aggregator node publishes the block and the header to the DA. Yeah, during that time, or even before that, the nodes already received this block, and they can actually do the verification. They can either verify header or verify block data, and PFB commitment. This is something we call soft confirmation. So it's if everything is fine and the state transition is valid, we say that it's soft confirmed, but it's still it's not included into the DA block yet. So after that, those nodes that already process this block, they can fetch, they can retrieve data from the DA layer, and if it's there, it means that it was included, and it's the point when we can say that it's hard confirmed. So it's basically like finality for this block. It's final for this block. So it takes time. First of all, the default finality for the block at Rollkit is 1 second, but for example for Celestia it's 12 seconds. Means that it's soft confirmed. It could be soft confirmed after 1 second, and like in the worst case 12 seconds for hard confirm. Okay, let's move on. Let's dig deeper a little bit into the interface. So we use GoDA, and it exposes like 7 methods. It's an abstract interface that allows to have like a drop-in replacement for DA, like Celestia. Right now we use 2 methods, which is get and submit. And what get does for the nodes, it allows you to basically get the blocks, like a list of blocks by IDs and by specifying namespace ID, and submit submits the blocks basically. Pretty simple. Yeah. Manu, you want to add something, or did I miss anything?
Yeah, so just to mention, like any DA layer, so Rollkit just interacts with the DA interface. So anyone can have an implementation for this DA interface, and they can use that layer as a DA layer. So currently we have a local version for testing, and we support Celestia. We have implementations for Avail, Celestia, and Bitcoin. But anyone can theoretically add that implementation to like this DA interface, and Rollkit just work out of the box with that. Yeah, that's another logic component.
Yeah, that would just require basically to implementing the interface. Okay. Let's move on. Yeah, open source contributions are welcome, as I said. You can go see what we do right now at the project tab, and you can see the issues which are marked. Okay. Now, what I want to do actually is a small demo. So first of all, we want to like showcase this the modularity aspect when you can substitute and swap different components. For example, the ones that are implemented by interfaces like state machine or DA. And the plan is to first go through our website, do the tutorial, and show how we do the no-op state machine, just with the one-liner. Then I suggest we try to spin up the custom WASM as a state machine, like a custom WASM rollup. And later I want to show how it's done, how we can swap the local DA, which is like a mock implementation of the DA, to the Celestia for Cosmos SDK app. Okay. And after that, we may have questions and maybe do something more if we have time. I think we do gonna have time, as it's just 16 minutes. Okay. So let me actually make it full screen. So here on the website, we have a quick start, and it's pretty simple. So you can try it easily. First, you need to actually let me refresh. Yeah. So the version is the latest. What you need to do, you need to just run the script to install the Rollkit. It's already installed for me. Let me actually check that. Let me make it a little bigger. So Rollkit version is 13.6. Okay. So how would I run this? Is just by doing Rollkit start. That's simple. So if I do Rollkit start, okay, wait, no peers. Okay, let me try it again. Yeah. So let's stop. So what it does, it just first of all, let's see. Yeah, service start. Yeah, and it starts. It has no seed nodes, working in aggregator mode. It's a default mode, and it starts creating and publishing blocks. So we ran it before, so that's why we have height 384. Okay, pretty simple. Everyone can do it. Now let's try to do a little bit more complicated with custom awesome. So on the tutorial section, we have a section for the execution, and we have a custom awesome rollup. So what is custom awesome? It's basically a WebAssembly engine that allows you to have a virtual machine, which is Cosmos SDK compatible. And we will try to integrate this with the local DA. So before that, like maybe a few weeks ago, we had a little bit bigger tutorial, which was covering all the steps. Right now, we switched to kurtosis. So first of all, what is kurtosis? It's a tool for packaging and launching environments of containerized services, the way you want them, how you want them, and using just simple command. Yeah. So and we released, we made it a package. So if you go to this website, for example, to this repository, custom awesome, Rollkit custom awesome, over here, yeah. Here it is, like a small repo with the two files, kurtosis.yaml, which specifies what is this package, and main.star, which actually explains what should be done under the hood. So if we didn't use kurtosis, we would need to run, spin up the local DA manually, like building it and running it, and same for the wasm-d. And here you can see this is the Python script where we start the DA, which is imported from another repository, by the way, local DA. Let's look at this as well. Yeah, so make build and build local DA, which would spin up the DA on 7980, and custom awesome rollup itself. So some ports and the start command, wasm-d start. So it's Rollkit aggregator mode, DA address. This is the way we specify the how to connect to the local DA using this flag. RPC, gRPC, PTP, okay. And if we wanted to run, for example, like real DA, like avail of Celestia, we would need to specify a few different flags, but we will get to that later. And that's it. Let's try to do it. I think I had it somewhere over here. Let's select client. Okay, let's just follow the tutorial and see how it goes. Not here, over here. Okay, let's do kurtosis run. So it created an enclave, dry awesome, just random name. Started the engine. Now it spins up the local DA, and the custom awesome rollup itself, which is like prepared for that. So let's do Docker PS. So it uses Docker under the hood, and as you can see, we have a custom awesome, which is this container running on port, exposing mapping some ports, yeah, and the port for the local DA as well is mapped 7980. Okay, and some more stuff, kurtosis stuff. Okay, now let's do this. First of all, yeah, as I did for Docker PS, let's try to write into the variable the name of this container, and yeah, we may do actually later on. We may just try to deploy and do some interaction with the contract actually in that. Right now I just want to do Docker logs to see the logs of the running. Okay, this is the Rollkit logs of the running Cosmos rollup. As you can see, it does block execution. Okay. Okay. Now we may if you want, we may come back to this later and to play with the contract a little bit. Now I want to show how we swap the DA component, DA layer. So for that, I suggest the easiest would be to just follow the tutorial as well. So if we go to the Rollkit Wordle app, here there is a big tutorial which uses Ignite CLI. It allows you to scaffold with Ignite the chain. Then we do some, yeah, by the way, we have Ignite app. It's called Rollkit. And you can just add it to the scaffolded app, Cosmos SDK app, and it will be included. And basically, like before that, we need to replace in a Go mode the command BFT, but right now you can just do this, and it will do the same. It will replace the engine. Okay, so I did all that right now. This tutorial is pretty interesting. It does some changes to the keepers, to the logic, basically the Wordle game, CLI Wordle game. Yeah, and over here we need to run the local DA. I think we already have the local DA running. Yeah, it's already running from the previous rollup, which is still up. I might actually kill it. Let me. No, I'm not going to kill it. I'll use it. And this is the command. How would I build it? So I need to ignite chain build. This would just build my binary and initialize the chain config using ignite Rollkit init. And I specify the flag local DA because it's local DA. So let's try to do it first. I have Wordle over here. Okay, this is the Wordle. Let's try to do like this. Okay, so it installed Wordle D binary. I need added chain config over here. Okay, and here's the genesis, by the way. Okay, now what I want to do, using the Rollkit CLI itself, I want to create some configs. I think it's already there, but yeah, I'm going to remove it for now. Let me make it a little bigger, yeah. And I'm going to do Rollkit only init. Okay, so what it does, it just it specifies the entry point and the directory where the configuration is, so we can maybe move it, or we can run this the Rollkit subcommand from any other subtree, like any other place of this in the subtree, and it will resolve the correct binary, the correct rollup, and the correct chain config. Okay, now how would I run this rollup? What I need to do is Rollkit start, which under the hood would spin up this Wordle D binary basically, but now it's called entry point over here, yeah. And we specify the DA address, which means that we specify where to connect. Let's try to do it. Okay. Okay, this is it. So, and the rest of the tutorial is for, we could spin up, open another terminal and try to do some transaction, submission, and stuff like that. Like, it's very interesting, and anyone can follow it. Now I want to try to switch from the local DA Let me get back. Yeah, from the local DA as I specified here to the Celestia, for example. So for that I need to spin up the Celestia node, Celestia Light client, which is, I pre-installed it. Actually, let me go here and show a little bit. So this is another tutorial which tells you how to run, which points you where to get information, how to run Celestia Light node. We have like different networks, and it requires you to pass the previous tutorial, which is GM World. We skip that. We just go over here. Yeah. So how would I connect to DA layer instead of local DA? I would just need to remove the previous flag for the local DA address and put these three: local Rollkit DA start hide, auth token, and namespace. Okay. And this is the command. How would I do this? Let me do this. So first, I would just get the block height. I'll first start this one. Okay. Now block height, auth token, and the default namespace. Okay, and now I would do Rollkit start. Okay. Okay, it works. Okay, this is it. Let's go back to the presentation. Now, I'd like to hear from you. Do you have any questions? And maybe what would you like me to play with? Or maybe actually Mano has anything to say. Do you want to add something?
Not really. This is great. Let's go to questions.
Okay.
What would I do then?
Okay, you have any questions?
Yeah. How does a state machine talk to Rollkit, and is it like through like an interface?
Yeah, so as I said, Rollkit is a common BFT replacement. The question is, how does state machine talk to Rollkit? Through the ABCI++ interface. So basically, it's initiated by the Rollkit. So you know what ABCI is, right? Yeah, so it has to implement that basically. But under the hood, it could be like any kind of state machine, you know. Like I can write my own custom state machine that would just implement this interface, and that's why you can replace it easily. You can just if I wanted to.
And
Okay, go on.
We're working on something called generalizing this, so it's not just ABCI. It can be an execution interface. So like different VMs, like the EVM uses something called the engine API. The SVM developers just released an interface called ANSA API to talk up to them. So you can have an interface where ABCI, engine API, and ANSA are just implementations. And so a Rollkit node can just talk to any of these state machines directly. So Rollkit is agnostic of the state machine. It's just, think of it as just like the glue for all these modular components.
Yeah, and I saw Connor from Celestia have a repository which makes a Rust implementation for this. So it allows you to wait. What was the name of this repository? I don't remember.
It's called Cinedarium, is the Penumbra one, and then the one Connor had is called Minnow.
Minnow. Yeah. So it could be not just Rust, it could be any language, basically. Just protobufs, basically. Okay. Any other questions? Yeah, as you can see, it's pretty simple, pretty easy to use. It gives you the flexibility. For example,
What is the question?
No,
Can you repeat the questions?
there are no questions anymore. I just say that Rollkit gives you the flexibility and ease to ship faster, basically. that you can just build the Cosmos SDK app, for example. Like
Yeah, but you can go to market really fast with a rollup and while having all the capabilities that you might be used to with a full-fledged blockchain. So a rollup is a blockchain.
and we discussed yesterday with the scenario when you want a prototype and maybe like settle on Rollkit for a while, and then you might want to switch to be the like chain with a set of validators, its own consensus. And we decided, like, we came up to the conclusion that it does make sense. Like, it does make sense to switch back from rollup, especially considering the final state of the Rollkit. I mean, so right now we have many stuff in progress, but if we have sequencing API done, if we have proof schemes done, validity proofs, not just pessimistic ones, light clients. So it's all in progress, and when it was done, it does make sense to switch back to the L1. Okay. What should we do now, Mano? We have still some time. We still have.
We can end early. That's fine. I think
Okay.
it's good. We have like 8 minutes remaining. Not a big deal.
Was it clear regarding the transaction flow, by the way?
Yeah. I mean, it's pretty good.
Okay. I was asking guys in a room.
Oh, I couldn't hear your question. What was your question?
Now my question was it clear regarding the transaction flow? Because I think I was a little too fast, and yeah, pretty simple. Okay. Yeah. Okay. And thanks for coming, and thanks, Mana, for assisting and helping. I think this is it.
Of course, thing. Nothing.
Sorry, I came late. I was at a event. My name is Ryan from Meta 11.
From where?
Meta 11.
Maybe 11.
Yeah.
Nice to meet you.
You guys are. So I don't want to like disrupt your flow because it's also recorded as well.
No, it's done. It's
Yeah.
all you.
Oh, is it? Yeah.
You can talk, yeah.
Yeah, but like so essentially you're just making it like easier for you guys to deploy a sovereign blockchain and like create your own. I guess like for everybody to like create their own blockchain on their own DM, for example.
Yeah, the point of this framework is, like as I said, to empower developers to create rollups faster, because you're welcome. Because it's actually easy to build a blockchain on the Cosmos SDK, but still it requires some operational stuff and the costs, incurred costs, and like infrastructure and and a common BFT. You're right. Yeah. So with Rollkit, you can. It's like it's really a small engine which is very modular and very like abstracted in terms of interfaces. It's written in Go, and you can basically customize it as you want. You can even actually, in theory, like if you're not satisfied, you can fork and like dig into it and maybe change something. But overall, like any component can be substituted. For example, as Mana mentioned, go on.
Go to the slide with all the components, collection interfaces. It's a good one to show.
Yeah, you can. You see there is a Bitcoin DA layer. So what it means that Bitcoin, which is the like separate blockchain with its own like script, and it could be done as a DA layer. So it's pretty cool. Like pretty cool that you can.
So you guys are trying to like combine everything in this case, because can you help me like explain like what?
Yeah, we're not trying to combine. We try to make it modular and make it replaceable and make it easy to do it. So It's basically decoupling, yeah. So as any good software is built using the primitives like how it's called, abstraction and generics, stuff. And and here we have like interfaces which could be implemented. So for example, DA layer, as I said, just like 6 methods, but we really use 2 methods, which is submit and get.
Right.
So bridging, IBC client, for example, we use, by default, it's Tendermint 007, could be anything else, like sequencing. Right now we have a centralized sequencer. That's the main, that could be the main like argument that it's like a centralized. But in reality, there are many like bonuses coming with that. Like for example, it's fast.
Yeah.
It doesn't, how it's called, it's fast, lightweight, and there is no governance or like.
The rules
What's the benefits of centralized sequencer again, Mano?
What are the what?
The benefits of a centralized sequencer at this point.
Oh, it's just like a fast go to market. You don't have to bootstrap a bunch of validators, right? And then you can also have super fast block times. Like it's only like 1 round trip global internet latency. So like that's like 150 milliseconds, 200 milliseconds. So your block time can be really fast. And it's really like kind of really dependent on the state machine, on how state commitments and execution works, right? So that's an advantage, but like we're adding working on the sequencing API, which is basically going to allow you to delegate sequencing to another layer. So there's shared sequencers coming to market, like Astria, Espresso, right? So you can use them as well,
right?
But then in that case, Rollkit, like the Rollkit node will just be a header producer. It'll just be pulling blocks from there.
Yeah.
You can also have base mode, so you can use the DA layer as like the DA layer blocks as your rollup blocks as well. So you can kind of like pick and choose between these different modular components and like basically build whatever you want. Right? That's kind of what is
Got it.
one of them.
Got it.
Yeah.
Yeah. Cool stuff.
So,
What can you say on the state validity mode?
oh, for state validity mode? State validity mode, right now, like you can run a full node if you want to verify the chain, just like any other blockchain. Right? So like there is, and then what we're going to add, like what we have in the most immediate roadmap is we are going to look at all these like CKVMs that are in market and going to integrate them so that starting with the EVM. So there's a bunch of like work being done on like Reds just came to production, the RIS0 ZKVM just came to production. So we want to kind of integrate them and have an option so that you can run an EVM rollup easily with with a ZKVM. And then we're going to add optimistic mode, which is you will only generate ZK proofs when there's a
Right?
oh, you will only generate a ZK proof when there's a dispute in that case.
Okay.
But yeah, you can kind of pick and choose between these modes on how the rollup talks to different other chains and how it'll have bridges. But yeah, you can theoretically support any of these things. So
Yeah.
that's what I'm going towards.
Got it. Interesting.
Yeah.
All in one kind of toolkit in that sense.
Yeah.
I think it's natural, if Rollkit wouldn't appear, someone else would do it, basically.
Yeah. But then, like, what's like driving you guys to continue like developing and like being better? Like, what's the incentive?
It is Rollkit is an open source like credit union public good. So
Yeah.
it is there's a team that's supported by Celestia Labs.
Right.
Right, and it is like in the incentive is really like to make it really easy for anyone to experiment, use all these components.
Is there any like issues when like the underlying technology changes with one of like the DA layers, bridging and sequencer? Like what's the impact on you guys?
What do you mean? What do you mean changes?
Like in terms of like the implementation, like maybe one of the I mean, because you're abstracting all the functionalities of the different sequences, DA layers, bridging, and like wouldn't there be like a delay in terms of like being able to support that functionality?
That's a good question. So I think the goal kind of is that so for example like the DA layer, right? Like Avail, like since Rollkit is a team because if the Avail implementation changes, then there's a team that their team actually maintains that implementation.
It's a client stuff, So if they change, it's on their interest basically to.
Oh, okay. So you guys are working together with them to like.
It's more like they know the interface and they can just go and update the client for them. That's it. So that's what you mean, like if they change their underlying like API or something, is that what you mean?
Yeah.
Yeah. So we cannot do this, or they can do it. Like they just.
We don't need to own it. We can have teams of different components. Like if there's users, right, they have an incentive to go and support that and change it.
Yeah.
So that's kind of like how we want to take it. We don't want to like work on all these different components and maintain all of them. That's not sustainable. And so having these teams own it, like if there's users for these, then there's a natural incentive for them to do it, right? And oftentimes it creates like an alignment sort of around all of these different components on how like for them to contribute to Rollkit. So for example, the Avail team, which contributed to the implementation for their thing to Rollkit, they've been also working on generally Rollkit issues. So we kind of expect that to happen more and more with shared sequencers, with like execution stuff. So that's kind of like the vision for it.
Yeah. Well, okay. Just want to add that, for example, the tool I used, Kurtosis, is also contributing to Rollkit, so they created packages for us.
Okay. Cool.
Sounds good.
Sounds good. Yeah. And don't be obliged to like stay here or anything. Yeah.
Yeah. Sure. Have a good day.
Thank you for your presentation.
Yeah, thanks for coming.